So something the A-level board likes a lot are waters of crystallization, using percent compositions and so forth. So a series of questions associated with those. So nitrogen forms several oxides. Who cares? Because we're talking about hydrated calcium nitrate. CaNO3 twice dot X. So guess what we're going to be doing here? A 6.04 gram sample of that whole thing contains 1.84 grams of water. Calculate the value of X. Now the way that we're going to do all of these problems is ultimately looking at moles and ratios of moles. Okay, so we start off with 6.04 grams of this stuff, and that 6.04 grams is made up of water and calcium nitrate. Okay, we know that it's 1.84 grams of water, which means that the calcium nitrate part must be 6.04 minus 1.84, or 4.2 grams of calcium nitrate. Now, anytime you see grams of pure substance, convert it to moles. So that's 0.102 moles of water and 0.0256 moles of calcium nitrate. Now, take your time calculating the molar mass of calcium nitrate, but it does come up to being 164 grams per mole. So in other words, for every 0.0256 moles of calcium nitrate, we have 0.102 moles of water. Let's see what the ratio is. And the best way to do that is just divide by the smaller number. So divide by 0.0256. And that gives us 1 calcium nitrate to 3.98 waters. Between friends, why don't we call that 4? Okay, so 4 waters for every calcium nitrate, determined by first of all getting the masses of each one, then converting those to moles, and then looking at the ratio of the moles. So pretty much the same type question. We've got oxalic acid as a hydrate, so oxalic acid with some unknown numbers of waters. On heating it, water is lost, leaving the anhydrous. And here's a little equation they give us to show us that whole thing going on. Much more importantly, 5.67 grams of the hydrate were heated to constant mass, from which we got 4.05 grams of the anhydrous acid. So there you are. So of course, the difference there, the 1.62 grams, is the water that was driven off. So we've got the relative number of grams of the oxalic acid in the water. Anytime you see grams, convert to moles. So divide by 18 for water, divide by 90 for the oxalic acid. And you see 0.09 to 0.045. Make it a nicer ratio by dividing by the smaller number. And we get 2 waters for every oxalic acid. Now we've got strontium hydroxide with a hydrate. Again, heat the strontium hydroxide hydrate, giving off the water, leaving you with the strontium hydroxide. Mass of hydrated strontium hydroxide of 11.95 grams was heated and produced 5.47 grams of anhydrous strontium hydroxide. Okay, what's the difference? Well, the difference is water, 11.95 minus 5.47 is equal to 6.48, and that's the water. Again, got the relative grams, divide by the molar masses, and we get 0.0449 moles of strontium hydroxide to 0.36 moles of water. Divide by the smaller number, 0.0499, and that gives us 8. So X in this case is equal to 8. So in 2019, in Unit 1, they started talking about calcium chloride, which can exist as an anhydrous salt or the hydrated salt here. So an experiment to determine the extent of hydration, sample of the hydrated calcium chloride, so 3.29 grams, was heated to remove all the water. The solid remaining had a mass of 1.67 grams, and that is, of course, 1.67 grams of calcium chloride. 3.29 minus 1.67 is 1.62 grams of water that was driven off. Usual process, convert to moles. We divide by the smaller number, so 0.015, and so we see is that there's 6 moles of water to every 1 mole of calcium nitrate. X equals 6. Now in 2019, they really liked calcium chloride because this is what was in Unit 3 as a question. So let's do it, shall we? Just because same thing, so same idea, drying process. We got 5.2 grams of the hydrated calcium chloride, 3.15 grams of the calcium chloride, and the other remaining 2.05 grams is water. Convert as appropriate to moles. Now we divide through by 0.0284, so we got 1 mole of calcium nitrate goes with 4.01, call it 4 moles of water. So obviously the calcium chloride, as you move from unit 1 to unit 3, loses a couple of molecules of water. Now we move to a slightly simpler type of problem. Hydrated compound, ester hydrated again with D, so this is what we're calculating, contains an S-blot metal ion M and a halide ion Z. When a 0.02 mole sample of this compound heated to constant mass, 1.44 grams was lost. Now that 1.44 grams is of course 1.44 grams of water, which is 0.08 moles of water. And that came from 0.02 moles of the compound. So you can see that this question is phrased in a way where we don't have all the stuff in there. They just straight off tell us the number of moles and the mass of water, which we convert to moles. Usual process, divide by the smaller number to get a nice ratio where we see that X is 4. This is actually the same problem with this cadwalladerite, because here we have this big messy stuff that's got D, which is a metal ion, E, which is a halide, hydroxides. Don't really care about that here. What we do care about is we got X waters associated with it. And so jumping through the process, 0.023 moles of cadwalladerite heated to constant mass. The mass loss was 1.658 grams. That's obviously the water. Convert that to grams. To moles, excuse me. So now we got 0.0921 moles of water, and that came from the 0.023 moles of cadwalladerite that we had there. So therefore, usual process, divide through by the smaller number, and we get 4. So X is equal to 4 in cadwalladerite. Now, this question 12 from 2016, the old Unit 2, continued on talking about cadwalladerite in a type of question that's very similar conceptually to what we've been discussing. So let's now leap past waters of hydration and move on to actually determining formulae.